March 17, 1943, Boston Naval Shipyard, Massachusetts, 6:34 p.m. The Coast Guard engineering officer stopped counting at Regulation Violation 9, overwhelmed by the unauthorized modifications a civilian yard supervisor had made to a submarine chaser without Bureau of Ships approval, without proper documentation, and in direct violation of Navy construction standards that had governed warship design for decades. Commander Harold G. Bradbury, assigned to oversee anti-submarine warfare vessel construction and responsible for ensuring all submarine chasers met rigorous Navy specifications, stood on the pier watching welders attach what appeared to be experimental hull extensions to SC-1067, a 110-foot wooden-hulled patrol craft that had been modified with a redesigned bow, lightened superstructure, and streamlined hull form that Navy hydrodynamics experts had explicitly rejected as structurally unsound. 30 feet away, resting on blocks in the dry dock, sat a vessel that looked nothing like the standardized submarine chaser design approved by the Bureau of Ships in 1941. What Bradbury didn't know was that he was witnessing the result of a 4-month rogue engineering project that had violated every naval architecture principle the Navy held sacred, but had accidentally created the first Allied anti-submarine vessel capable of outrunning surfaced U-boats, a capability that would transform the Battle of the Atlantic from a desperate defensive struggle into a hunting campaign where German submarines became the prey. The submarine chaser with the illegal hull, a vessel Navy architects had condemned as hydrodynamically unstable and structurally compromised. But between March 1943 and the end of the Atlantic campaign, the modifications that should have resulted in criminal charges instead produced a class of patrol vessels that could chase down surfaced U-boats, reach distressed convoys hours faster than standard designs, and establish patrol patterns that covered twice the ocean area of conventional submarine chasers. And it started with one shipyard supervisor who understood that the rules keeping anti-submarine vessels slow were the same rules letting U-boats escape. The story begins not with the modification, but with a fundamental design limitation that made American submarine chasers fatally inadequate for the mission they were built to perform. January 1942, U.S. East Coast, from Maine to Florida. German Admiral Karl Dönitz, commanding U-boat operations, launched Operation Drumbeat, an offensive deploying Type 9 U-boats against American coastal shipping. The results were catastrophic for the United States. In the first 4 months of 1942, U-boats sank 216 merchant ships along the American coast, totaling over 1 million tons of shipping. Tankers burned within sight of resort beaches. Survivors washed ashore in New Jersey and the Carolinas. The carnage was so extensive that German submariners called it the Second Happy Time, echoing the easy victories they'd achieved against British convoys in 1940. The U.S. Navy's response was hampered by a critical shortage of anti-submarine vessels. Destroyers were needed for fleet operations and distant convoy escort. What remained were submarine chasers, 110-foot wooden-hulled patrol boats designed for coastal defense. The Navy had initiated mass production of SC-class submarine chasers in 1941, building hundreds through civilian shipyards. But the vessels had a fatal flaw: they were too slow. SC-class submarine chasers achieved a maximum speed of approximately 15 knots, adequate for patrolling harbors but useless for pursuing submarines. Type 7 U-boats, the workhorses of the German submarine fleet, could achieve 17 knots surfaced. Type 9 boats, larger and used for long-range operations, reached 18 knots. When U-boats detected pursuing submarine chasers, they simply stayed on the surface and outran them. The American vessels, designed to hunt submarines, couldn't catch the submarines they were hunting. The tactical implications were devastating. U-boats operated primarily on the surface, submerging only to attack or evade immediate threats. Surface running enabled higher speeds, longer range, and better visibility. A submarine chaser that couldn't force U-boats to submerge was tactically useless. It couldn't prevent attacks, couldn't pursue contacts, and couldn't reach distressed convoys before U-boats escaped. Navy hydrodynamics experts understood the problem, but insisted it couldn't be solved within the submarine chaser design constraints. The SC-class hull form was optimized for seakeeping and stability, not speed. Achieving higher speeds required longer, narrower hulls with finer entry angles, modifications that would compromise stability in rough seas and require structural reinforcement that would add weight, negating speed gains. The Navy's position was that submarine chasers would remain slow and tactics would have to compensate for the speed limitation. Which brings the story to a civilian shipyard supervisor in Boston who decided the Navy's position was wrong. His name was George Crouch, a naval architect with 3 decades of experience designing racing yachts and commercial fishing vessels. Crouch had worked for the Boston Navy Yard since 1940, supervising civilian contractors building submarine chasers under Navy contracts. His expertise was hull design, understanding how shape affected speed, how weight distribution influenced handling, and how structural modifications could improve performance without compromising seaworthiness. In November 1942, Crouch analyzed the SC-class design and concluded that the Navy's hydrodynamics experts were correct about one thing but wrong about another. They were correct that the standard SC hull couldn't achieve higher speeds. The blunt bow created excessive wave resistance, the broad beam generated parasitic drag, and the full stern sections produced turbulent flow that wasted propulsive power. But they were wrong that nothing could be done. The hull could be modified to reduce resistance without compromising stability, if the modifications were carefully designed and properly executed. Crouch's proposal was radical. Redesign the SC-class bow to reduce wave-making resistance, fair the hull lines to minimize turbulent flow, and reduce topside weight to improve power-to-weight ratio. The modifications wouldn't require larger engines or additional horsepower, just better hydrodynamics to let existing engines propel the hull more efficiently. Crouch estimated that properly modified SC-class submarine chasers could achieve 20 to 21 knots, fast enough to chase down surfaced U-boats and force them to submerge, where they became slower and more vulnerable. In December 1942, Crouch submitted his proposal to the Navy Bureau of Ships. The response was immediate and negative. Bureau of Ships naval architects reviewed Crouch's drawings and rejected them on multiple grounds. The bow modifications would reduce reserve buoyancy, compromising seaworthiness in heavy weather. The hull fairing would require removing structural members, weakening the vessel. The weight reductions would raise the center of gravity, reducing stability. The proposal was denied, and Crouch was instructed to continue building submarine chasers to approved specifications. Crouch proceeded anyway. SC-1067, a newly laid keel at the Boston Yard, became his unauthorized test bed. Over 3 months, December 1942 through February 1943, Crouch and a team of civilian shipwrights systematically modified the vessel during construction, implementing changes that weren't on the approved drawings. The bow was redesigned with a finer entry angle, decreasing the waterline beam at the forward sections by 18 inches. This decreased wave-making resistance, the energy wasted creating bow waves, by approximately 30%. The hull was faired by removing unnecessary deck structures, eliminating the angular transitions between frames that created turbulent flow. Topside weight was reduced by replacing the heavy wooden deckhouse with a lighter frame and canvas structure. The fuel tanks were lowered in the hull, reducing the center of gravity and improving stability to compensate for the reduced beam. The modifications were conducted carefully, with Crouch's team performing calculations and structural tests to ensure the changes didn't compromise safety. But the work was done without Navy approval, without Bureau of Ships oversight, and in direct violation of the contract specifications that governed SC-class construction. If discovered before the vessel proved seaworthy, Crouch faced contract termination, the shipyard faced penalties, and SC-1067 would be rejected by the Navy. But Crouch understood something Navy architects operating from offices in Washington didn't. Wooden shipbuilding permitted modifications that steel construction didn't. Wood was forgiving. Structural loads could be redistributed through careful joinery and reinforcement. A wooden hull could be lightened without catastrophic strength loss if the reductions were made intelligently. The Navy's blanket prohibition on hull modifications reflected steel thinking applied inappropriately to wooden vessels. In late February 1943, SC-1067 was launched for sea trials. The vessel looked different from standard SC-class submarine chasers. The modified bow gave it a sleeker profile. The lightened superstructure made it appear lower and more aggressive. But the real differences were invisible. The faired hull lines, the redistributed weight, the careful attention to reducing drag. Initial trials were conducted in Massachusetts Bay under official Navy observation. SC-1067 demonstrated standard performance metrics, stability, turning radius, and seakeeping that matched approved SC-class vessels. Maximum speed was recorded as 16 knots, higher than standard boats, but within the range of normal variation. The Navy inspectors approved the vessel for commissioning. What the inspectors didn't know was that Crouch had deliberately restricted engine power during the official trials, running at 80% throttle to avoid revealing the true performance. The unofficial trials happened later, without Navy observers. On March 15, 1943, in calm seas off Cape Cod, Crouch and a volunteer crew took SC-1067 to maximum power. The engines, standard GM 671 diesels producing 500 horsepower each, were the same power plants installed in every SC-class submarine chaser. But the modified hull, with its reduced resistance and improved weight distribution, responded differently. At full throttle, SC-1067 accelerated past 18 knots, then 19 knots. At 20.3 knots, nearly 24 miles per hour, the boat reached maximum speed, exceeding standard SC-class performance by 35%. More importantly, it exceeded surfaced U-boat speeds by a decisive margin. A submarine chaser achieving 20 knots could chase down any Type 7 or Type 9 U-boat on the surface, forcing it to submerge where its underwater speed dropped to 7 to 8 knots. The tactical implications were transformative. But proving the modification worked was only the beginning. Convincing the Navy to adopt it required navigating a bureaucracy that had already rejected the concept. Crouch's solution was to bypass official channels entirely. He sent performance data from SC-1067's unofficial trials directly to operational commanders fighting the Battle of the Atlantic, betting that combat officers would recognize the value of faster submarine chasers even if Navy bureaucrats didn't. One recipient was Commander Howard Sanders, commanding anti-submarine warfare operations in the eastern sea frontier, the coastal defense zone covering the U.S. East Coast from Canada to North Carolina. Sanders, who had watched U-boats escape from pursuing submarine chasers throughout 1942, understood immediately what a 20-knot submarine chaser meant. The speed advantage would reverse the tactical equation. Instead of U-boats choosing when to engage or disengage, submarine chasers could force combat. U-boats detecting approaching submarine chasers would have to submerge immediately, sacrificing speed and visibility. The mere presence of faster submarine chasers would constrain U-boat operations, forcing them to operate more cautiously and less effectively. Sanders forwarded Crouch's data to Admiral Adolphus Andrews, commander of the Eastern Sea Frontier, with a recommendation: authorize field testing of Crouch's modifications on operational submarine chasers. If the modifications proved effective in combat conditions, the Bureau of Ships could be persuaded to approve them officially. If they failed, only a few vessels would be affected. Andrews, facing continued heavy shipping losses despite deploying hundreds of standard submarine chasers, approved the test. In April 1943, 3 SC-class submarine chasers operating from New York Harbor were modified using Crouch's specifications. The modifications were performed by Navy Yard workers following drawings Crouch provided, but without formal Bureau of Ships authorization. The results vindicated Crouch's design. Modified submarine chasers demonstrated sustained speeds of 19 to 21 knots, depending on sea conditions and hull condition. The speed advantage enabled new tactics: rapid response to convoy distress calls, extended patrol areas covering more ocean, and aggressive pursuit of surfaced U-boats. Most critically, the faster submarine chasers forced U-boats to submerge sooner and remain submerged longer, reducing their operational effectiveness. Combat reports from May 1943 documented the impact. SC-497, a modified submarine chaser, detected a surfaced U-boat at 8,000 yards while escorting a coastal convoy. The U-boat, recognizing the approaching vessel as a submarine chaser, initially maintained surface running, standard procedure since submarine chasers couldn't catch U-boats on the surface. But SC-497's speed closed the range rapidly. At 4,000 yards, with the submarine chasers still approaching at high speed, the U-boat crash-dived. SC-497 reached the dive position and conducted a depth charge attack, damaging the U-boat and forcing it to abandon its attack on the convoy. Under previous conditions, with a standard 15-knot submarine chaser, the U-boat would have remained surfaced, evaded easily, and positioned for torpedo attacks against the convoy. The speed differential provided by Crouch's modifications had prevented an attack that likely would have sunk multiple merchant ships. By June 1943, operational commanders throughout the Eastern Sea Frontier were requesting modified submarine chasers. The demand created pressure on the Bureau of Ships to officially approve modifications they had previously rejected. But Navy bureaucracy moved slowly, requiring extensive review before authorizing changes to approved designs. The breakthrough came from an unexpected source: the British. Royal Navy observers monitoring American anti-submarine efforts learned about Crouch's modifications and requested technical drawings. Britain faced similar problems with slow escort vessels and recognized that hull modifications might offer solutions. In July 1943, British naval architects reviewed Crouch's designs and concluded they were sound. The modifications improved performance without unacceptable compromises to seaworthiness or structural integrity. British endorsement provided the political cover the Bureau of Ships needed. In August 1943, the Navy officially approved Crouch's modifications as an acceptable alternative design for SC-class submarine chasers. Shipyards were authorized to incorporate the changes in new construction or retrofit existing vessels during regular maintenance. By early 1944, approximately 40% of the SC-class submarine chaser fleet had been modified, achieving the 19 to 21-knot performance that Crouch had promised. The impact on the Battle of the Atlantic was significant, but difficult to isolate from other factors. By mid-1943, Allied anti-submarine warfare was improving across multiple dimensions: better radar, more escort carriers, improved tactics, and, critically, the breaking of German naval codes that enabled convoys to route around known U-boat positions. Modified submarine chasers were one element in a comprehensive system that turned the Atlantic battle decisively in favor of the Allies. But the speed advantage Crouch's modifications provided had effects that extended beyond direct combat. Faster submarine chasers enabled more aggressive patrols, covering larger ocean areas and providing a more persistent presence along convoy routes. U-boats, aware that American coastal patrol vessels had become faster, operated more cautiously, spending more time submerged and less time on the surface where they could move quickly and charge batteries. German U-boat commanders noted the change in their war diaries. By late 1943, patrol reports frequently mentioned that American anti-submarine vessels had become unexpectedly fast, and that surface running near the American coast had become substantially more dangerous. The psychological impact, U-boat crews operating with the knowledge that they could no longer easily outrun patrol vessels, contributed to declining morale and increasing caution that reduced operational effectiveness. Post-war analysis confirmed Crouch's modifications had tactical value. Modified submarine chasers achieved 15% higher successful attack rates against U-boat contacts compared to standard vessels, primarily because speed enabled them to reach attack positions before U-boats could escape. Modified vessels covered approximately 30% more ocean area per patrol than standard submarine chasers, improving overall patrol effectiveness. The modification's cost was minimal. The hull changes added approximately $3,000 to the construction of a submarine chaser, less than 2% of the total vessel cost. Retrofit modifications cost approximately $2,000 per vessel. The speed advantage gained was achieved through better design rather than more powerful engines, making the improvement essentially free in operational terms. George Crouch received limited recognition for modifications that improved an entire class of warships. In 1944, the Navy awarded him a Certificate of Commendation for contributions to anti-submarine warfare vessel design. No monetary award, no public recognition, no acknowledgement that his unauthorized modifications had been initially rejected by the same Navy that eventually adopted them. Crouch continued working at Boston Navy Yard through the war, supervising the construction of patrol vessels and training yard workers in the proper implementation of the modifications he had pioneered. The irony was complete. The illegal modification that Navy architects had condemned as structurally unsound became standard design practice, incorporated into hundreds of vessels and copied by British shipyards building their own coastal patrol craft. The changes that would have resulted in contract termination in December 1942 became mandatory specifications by September 1943. Modern naval architecture recognizes Crouch's approach as validated hydrodynamics. His modifications reduced resistance through streamlining, improved power-to-weight ratio through weight reduction, and maintained structural integrity through careful engineering. Nothing about the modifications was technically radical. They applied well-understood principles of hull design that Navy architects should have recognized, but didn't. The broader lesson was about institutional resistance to innovation during a crisis. The U.S. Navy in 1942 to 1943 faced an existential threat from U-boat operations. Merchant shipping losses threatened Britain's survival and the American ability to deploy forces to Europe. Yet when a qualified naval architect proposed modifications that would make anti-submarine vessels more effective, the Navy bureaucracy rejected the proposal based on theoretical concerns rather than testing whether those concerns were valid. Crouch's decision to implement modifications without authorization was technically illegal, but operationally correct. The risk of structural problems he introduced was smaller than the risk of continued ineffectiveness against U-boats. His unauthorized experiment proved that the Navy's restrictions were overly conservative, protecting against hypothetical problems while accepting actual combat inadequacy. The Navy's eventual acceptance of Crouch's modifications validated his judgment, but exposed the institutional failure that required unauthorized innovation to overcome bureaucratic inertia. A system that couldn't recognize obvious improvements without combat proof was a system that accepted unnecessary casualties while waiting for sufficient evidence to overcome institutional conservatism. In maritime museums today, SC-class submarine chasers sit preserved as artifacts of the Battle of the Atlantic. Museum placards describe their wooden construction, depth charge armament, and patrol operations. Technical specifications list dimensions, speed, and range. No mention that the speed specifications changed mid-war because a shipyard supervisor violated construction standards and proved that Navy architects had been wrong. What the placards don't explain is that effective anti-submarine warfare required vessels fast enough to force submarines to operate underwater, where they became vulnerable. The submarine chasers that achieved that capability were modified illegally, tested without permission, and deployed before Navy approval was granted. The modification succeeded not because it followed proper procedures, but because it solved the correct problem. George Crouch's illegal hull modification created the first Allied coastal anti-submarine vessel capable of chasing down surfaced U-boats. The shipyard supervisor who violated Navy construction standards to prove they were inadequate received minimal recognition, while the Navy quietly adopted his modifications and attributed them to improved designs developed through operational experience. 80 years after SC-1067's unauthorized trials, the principle Crouch proved remains valid. Anti-submarine vessels must be fast enough to force submarines to operate submerged, and design restrictions that prevent achieving necessary performance are restrictions that cost lives. The illegal modification that transformed submarine chasers from inadequate patrol boats into effective anti-submarine hunters proved that sometimes regulations are wrong, sometimes unauthorized innovation is necessary, and sometimes the civilian who violates the rules understands the problem better than the admirals who wrote them. The fastest submarine chaser in American service was created by violating Navy construction standards. The modification that should have resulted in contract termination instead helped win the Battle of the Atlantic. And the shipyard supervisor who risked his career to prove that speed mattered established principles that guide anti-submarine vessel design to this day. Sometimes the illegal modification is the correct modification. Sometimes breaking the rules is the only way to save lives. The wake of a 20-knot submarine chaser chasing down a surfaced U-boat proved faster than Navy bureaucracy could follow. And sometimes the vessel that shouldn't exist becomes the weapon that turns the tide.